doing a screen recording because Microsoft PowerPoint is not my friend. So, this week we're going to be talking about memory. Woohoo! We're going to start with where it lives in the body, so in your brain, where memory, the parts of the brain that memory is associated with, and then we're going to get into how memories are formed. We're going to get into false memory and reshaping our memory and just the nature of memory. Okay, so let's get into it. Let's see. Please work for me. Please work for me. There we go. All right. So where do our memories live? The question here is, are memories stored in just one part of the brain, or are they stored in many different parts of the brain? So there was a researcher, his name was Carl Lashley, began exploring this problem about 100 years ago, probably a little over 100 years ago now. He wanted to make lesions in the brains of animals like rats and monkeys because that's what we've historically used in the lab when we experiment on animals. It's usually lab rats. And a long time ago, it used to be monkeys. And they might still do that a little bit, but it's definitely not as much since they kind of linked them to us. So, lesions, it's like making like injury, like burning parts of the brain. So he was searching for evidence of what he called the engram, I don't know how to say it, which was this idea of there was a group of neurons that could be the physical representation of memory. Like, what exact part of the brain is the part where our memories are? And if I can injure that, this is traditionally how we've studied the brain, is like, when I injure this part of the brain, what happens to me? What am I not able to do? And then that's their indication of, oh, well, that part of the brain must be responsible for that function. So he wanted to injure a part of the brain, and if we can't remember anything, then we would know, oh, okay, that part of the brain is responsible for our memory. Well, so Lashley first trained rats to find their way through a maze. This is so common in psychology. There's always rats and there's always a maze. Okay, so then the rats learned how to go through the maze. They learned the way. Then he used the tools available at the time. In this case, it was a soldering iron, which is a heat. Okay, so it burned lesions in the brain, specifically in the cerebral cortex, which is the outer layer of the brain. And he did this because he was trying to erase the engram, or the original memory trace that the rats had of the maze. So if he did this and then the rats couldn't find their way through the maze, he would know, okay, this is the part of the brain that has to do with memory. Well, it didn't happen. So what ended up happening actually was that the rats were still able to find their way through the maze, regardless of where he burned their brain or how big of a burn or lesion he made in the brain. So they were always able to find their way through the brain. So that led to what we call the equipotentiality hypothesis. So let's break that down. So think of equal, equal, and then potentiality, so the potential. So an equal potential hypothesis. That what that is that if part of one area of the brain involved in memory is damaged, then another part of the same area can take over that memory function. And this is actually true with more things than just memory. When we, my light died. I knew this was going to happen. I had a feeling. So with more things, look at the difference. Okay. So we had people who had severe seizures, and we were like, okay, let's cut split their brain in half. And what we found is that certain areas of the brain took over the other areas that were inactive. To It's kind of like a lizard regrowing its tail. I don't know if that's actually real. We think that's real, but mine didn't. My crested gecko did not grow its tail back, so I don't know what to say about that. But your brain does. It kind of, when one part is damaged, and other parts will try to take over as much as they can to maintain the functionality of the brain. So, although Lashley didn't confirm the existence of the engram, we are making other progress towards locating it. So we do have certain areas of the brain that are involved in memory. So many scientists believe the entire brain is involved in memory, and I would have to agree. I would extend it to the whole nervous system. Remember, the nervous system is not just the brain, but all of the nerves. And you'll see that relationship next class. But so Lashley's research, since his research, other scientists have been able to look more closely at the brain and memory. And they have argued that memory is located in specific parts of the brain, and specific neurons can be recognized for their involvement in forming memories. So we have found that there are 4 areas of the brain that are that light up most commonly when memories are formed and activated, meaning like I ask you to remember something. The amygdala, the hippocampus, the cerebellum, and the prefrontal cortex are our main ones. Does that mean that other areas of the brain are just kind of chilling and not active at all when you think about certain memories? No, of course not. There's little activation in all different areas of the brain. It depends, right? But we see these 4 mostly light up. So let's look at what these 4 are. Let's review. Amygdala. Okay, note this picture. What is going on? This is like a Frankenstein type character, right? Are you very scared? So this is pretty reductive, but you can think of the amygdala as, in its most simple sense, your fear response. Okay, so the main job of the amygdala is to regulate emotions. It does a lot of things with all kinds of different emotions, but we see it most active with fear and aggression. So the amygdala plays a part in how memories are stored. Because storage is influenced by stress hormones. So the more stressed you are, the more in fear you are, the more active your amygdala is going to be. The amygdala seems to facilitate encoding. Okay, so that's like storing of a memory, storing of an experience, encoding it in with meaning at a deeper level when an event is emotionally arousing. Okay, so the amygdala has to do with emotional arousal, and one of our main emotionally arousing emotions is fear, right? It's very, it's very emotionally arousing. It can quickly put you into fight or flight, and then you have your heart is racing. Okay, and then you have a lot of blood flow sent to your brain, and then the amygdala is active. So when we see that a region of the brain is active, it's because there's a lot of blood flow going there. So imagine you are walking through downtown of a city, and you start to feel like someone is following you. Okay, you can quickly start to get very stressed. Your heart starts racing. There's blood flow, and then you are in fight or flight. Okay. At that moment, the amygdala is like, boom, it's active. And what it's going to do is it's going to store the memory real efficiently. It's going to store the memory of where you are when this person is following you, what the person might be wearing, the sound of any sounds around you. You're going to start to remember, like, exactly, you're going to see where you are, what buildings are around you. You're going to take note of a lot of things, because I'm going to tie this to evolutionary psychology. Imagine if, how My dog's hairs are just in the air and they just keep landing in my most unregulated drug in the entire world, caffeine, coffee. So your brain, your amygdala is going to help you survive this in the next time, right? If you are going to remember this instance, this experience, this is one going to help you avoid whoever this person is if you can remember any details about them, survival, right? And it's also going to help you if you were to walk down this same path in downtown again, you're going to quickly be triggered into remembering, oh my God, this is where that person was following me before. I'm not going to come here again. I'm not going to come here again. So it's going to help you survive that. So that's what the amygdala does. Now, it's also, it's also active when you have emotionally arousing happy memories too. Anything that is emotionally intense is what the amygdala's job is for. It will highlight that time, and it'll help you to remember the emotionally intense experiences. This is why you might remember, that one time I don't know, the time you had to give a speech in middle school and you felt like you totally bombed it and you were really stressed and it was really scary. You're going to remember that time. You're going to remember the random embarrassing moment where you wanted to tell your crush that you liked him or asked him or her to the dance and they said no or whatever. It's going to, this big fear response inside of you. You're going to remember that way easier than you're going to remember what you had for dinner 3 weeks ago, right? Because the emotional intensity of it, so that you can either repeat it to help your survival or not repeat it to help your survival. Here we go. Hippocampus. Note this. What are we looking at? We're looking at a maze. We're looking at like a map, right? This mouse is remembering how to get through this maze, like a mental map to find the cheese. So what does that tell you about the hippocampus? So another group of researchers also experimented with rats and created lesions in the hippocampi. Hippocampi is plural of hippocampus. You have two. Remember, your brain is split. You got one on either side. You also have two amygdala. So I don't know if you would call it amygdalae, but hippocampi, one on either side of your brain, of the rats, and finding that the rats demonstrated memory impairment on various tasks, specifically object recognition and maze running. So recognizing an object, knowing where you've previously seen that before, and then maze running through a maze. So, you've created a map of how to get through this maze, and now you can't do it anymore because you can't recognize the parts of the maze, can't recognize what you learned before. All right, so let's dive deeper into those two things. So they concluded that the hippocampus is involved in memory, specifically normal recognition memory and spatial memory. Okay, hippocampus is super cool for a couple of reasons. Recognition memory. Hippocampus is in charge of remembering if you've met someone before, you remember their face. That's the hippocampus, recognizing someone before. Or walking through a place, going to travel and visiting a place that you were at when you were really young. And then you go there and you start to recognize, oh my God, I remember this ice cream shop. I remember this. That's the hippocampus, the recognition memory, as well as spatial memory. So creating like a map of where you are, creating a map of your world. Spatial memory, knowing... in your house, knowing where the bathroom is, knowing where the laundry is, in your city, knowing how to navigate to your school, to your job, to your best friend's house. Okay, now creating this mental map is what the hippocampus does. Now, the other thing tied to this that the hippocampus does is it projects information to cortical regions that give memories meaning and connect them with other memories. When you create a map, okay, you can't just like put your school in a random place. The way you know your school is because of all the things that are around the school. You know that it's next to this neighborhood. You know that it's next to the Wawa. Now you're giving it meaning by connecting it with other things. So imagine creating a map. And the hippocampus does this with our memories. It gives your memories, it gives your experiences meaning by putting it into context of other things around it. So when you recognize someone, you don't just like, you're not just like, sometimes you're like, wow, I recognize your face. But most of the times the next thing you're gonna do is like, where do I recognize you from? What was the context? So I met you here. I met you at church. I met you. Oh yeah, we were in that one class that one time, that long time ago. Oh yeah, I ran into you at the mall and this one time with my friends. And you're giving that memory, that recognition, that experience meaning, context. So that's what the hippocampus does. And in doing that, it plays a part in memory consolidation. So memory consolidation, you should know this. So I'm going to bold it. Memory consolidation is the process of transferring new memories into long-term memories. Okay? New memories into long-term memories. So the hippocampus is like, oh, I need to remember this for next time. I'm going to give it the context. I'm going to give it meaning. Okay? And then it's stored into a deeper part. Injury to the hippocampus results in the inability to create new memory. So you'll remember everything from before, but you will not be able to remember new things. If you move into a new house, you might always struggle with like where the bathroom is, where the shower is, where the laundry room is, where the kitchen is. Okay. Next one is cerebellum. What is this person doing in this picture? Riding a bike. What is the cerebellum? In charge of muscle coordination, mostly. Okay, so brainstem muscle coordination. So although the hippocampus seems to be more of a processing area for explicit memories, you could still lose it and be able to create implicit memories. So implicit memories are like procedural memory and motor learning. And classical conditioning, we're not there yet. If you take a psych, you'll learn about classical conditioning, and maybe we'll do it. I don't know. But thanks to your cerebellum. So your cerebellum, so explicit memories is explicit. You can state, oh, I remember you from here. Implicit memories are, you don't have like specific thoughts around these memories. You just remember, it's like muscle memory, right? So that's what motor learning is. So procedural memory is remembering the order of tasks. So you put you take the bowl out, and then you put the cereal in the bowl, and then you put the milk in the cereal. The order of tasks. You don't have to tell yourself every time that those exact steps. It's just kind of, it's the steps that you do. And it's like implicit. Not doing a great job of explaining this. Turning on the stove after placing a pot of water on top, right? So you put the pot of water on top and then you turn on the stove. It's like it's even like language too. You don't have to think about every word that you say before you say it in order to speak. That's the kind of memory that procedural memory does. So cerebellum is in charge of procedural memory and motor learning. So motor learning is muscle memory. Okay, so referring to your motor skills, like learning to ride a bike, your cerebellum will help you know how to ride a bike because your muscles, your nervous system is going to remember it implicitly. You don't have to tell yourself, okay, I have to put my feet here and then pedal my feet, and then I have to turn it to the right in order to turn to the right. You don't have to tell yourself those things. You don't have to explicitly remember those things in order to remember them. You just, you get it, and then it's there and you'll remember. So that's what the cerebellum is in charge of. And even though the hippocampus, if your hippocampus is damaged, you won't be able to make new explicit memories, but you will be able to learn specific tasks, like because of your cerebellum, you'll be able to learn how to, you know, how to brush your teeth, how to cook, how to unlock your door. There will be certain things that are tied to your muscles and your peripheral nervous system that will be able to be accomplished. All right, prefrontal cortex. What is this man doing? He is creating a plan. He is looking at all of the considerations, and he's like, creating a plan, right? Prefrontal cortex, that's what it's a higher order thinking. It's putting all these different things together into a plan. It's complex planning for the future. That's our main thing, and then it has to do with other stuff too. Rational thinking, getting away from your more limbic system emotional thinking, so your prefrontal cortex. Remember, your frontal lobe, prefrontal cortex is within the frontal lobe. Your frontal lobe is not developed until 25 to 27. 25 for women, 27 for men. So young people are operating on the limbic system in your decision making, more emotional decision making, until that's developed. And then you start thinking, wow, I should probably start a retirement fund. All right, so prefrontal cortex. In one study using brain scans, participants had to complete 2 different tasks, either looking for the letter A in words, which is considered a perceptual task. So if I'm reading this whole thing, I'm perceiving, right? I have to recognize the words with A in them. Okay, I see an A, I see an A, I see another A, I see another A. I'm perceiving an A, and I'm recognizing it. Or categorizing a noun as either living or non-living, considered a semantic task. Semantic has to do with meaning, okay? So perceiving an A is just recognizing the words that have A in it. Oh, there's a word with an A. There's a word with an A. I'm perceiving that A. A semantic task is giving it meaning. Is it living or non-living? Is that a living or non-living word? Noun. Or it's not a noun. Sorry, categorizing every noun. Study. Living or non-living? Non-living. Brain. Living or non-living?